Before sound, before even the notion of a beginning, there was a stillness so complete that the word silence cannot describe it. There was no time to hold it, no space to contain it, and no listener to hear it. It was not the pause between two breaths, it was the absence of breath itself. In that deep and endless quiet, everything that would ever exist was compressed into a single, trembling potential, the possibility of motion, the seed of sound. It was the waiting moment before the first vibration, before the first note of the universe's song, when even light was only an idea sleeping inside nothingness. In that waiting void, energy and time were not yet separate. They lay folded together, unexpressed, like thought before language. If one could stand in that stillness, though there was nowhere to stand, one might not see darkness, for even darkness requires the presence of space. There was only the invisible density of everything that would ever be, galaxies, stars, oceans, minds, all hidden in the hush of unformed existence. The silence was not lonely, because loneliness implies contrast. It was pure, infinite potential. It was the quiet heartbeat before creation, the pause before the drumbeat of being. Then, imperceptibly, something changed. Perhaps it was a fluctuation, a quiver in the fabric of nothing, or perhaps the silence had grown full enough to overflow. Whatever it was, that first shift marked the transition from stillness to sound, from eternity to time. The universe did not yet know it had moved, it simply expanded into being, like a held breath released. In that exhalation, energy found motion, and motion found rhythm. The cosmos began to hum, not with a sound that any ear could hear, but with waves of expansion, spreading across the newborn dimensions of space. It was the first echo, though there was no one yet to name it. Every particle, every quantum tremor, carried the imprint of that first vibration. Space unfolded as though it had always known how to stretch, guided by invisible harmonies that science would one day call physical laws. The silence before creation did not vanish. It lingered behind the new music of existence, shaping every frequency, every pattern. Even now, across the billions of years that separate the listener from that first instant, a faint residue of that original hum still drifts through the cosmos. A whisper we call the cosmic background, the last trace of the universe's first voice. To imagine that moment is to step outside the comfort of human time. It is to imagine a place where there is no before or after, where cause and effect dissolve. It is to sense, dimly, that silence is not the absence of sound but the space that makes sound possible. Just as night makes the stars visible, the void gave the first vibration its meaning. Without that stillness, the explosion of being would have been chaos without form. The quiet before sound was not an emptiness to be broken. It was the perfect balance waiting to transform into motion. The first echo was simply silence learning how to move. From that movement came heat, pressure, and light, the earliest traces of what would later become galaxies, suns, and the dust that dreams of thought. But long before stars were born, long before matter cooled enough to shine, the universe was already resonating with a hidden rhythm. Every fluctuation was a note in an unfolding melody. Every expansion was a drumbeat of destiny. In that sense, the first sound was not heard through ears but through existence itself. It was the cosmos recognizing its own capacity to become. The idea of an echo implies reflection, a sound meeting a boundary and returning. But in that first instant, there were no walls, no limits for sound to bounce from. The echo the universe heard was itself, a self-reflecting pulse of energy becoming aware that it was. It is almost a paradox, an echo without origin, a resonance without space. Yet this is how everything begins, from universes to human thoughts, with an unseen tremor in stillness, a whisper in the dark, a small disturbance that changes everything. To the human ear, billions of years later, that first sound would not be a melody but a vibration spread thin across time, a soft hiss that fills the background of existence. Astronomers have captured it with antennas and satellites, translating the invisible wave into something we can measure. But its essence cannot be contained in numbers. It is both a scientific phenomenon and a spiritual metaphor, proof that the universe was not born in silence but in sound, that creation itself is a kind of music and that we, as listeners, are still part of its reverberation. And so the story begins not with light, not with movement, but with the memory of silence. Because before sound could exist, stillness had to learn to tremble. Before the universe could sing, it had to listen to itself. In that endless pause before time began, the first note waited, unstruck yet inevitable, the sound that would awaken reality, the vibration that would echo through all that followed, until even now, as we drift to sleep beneath ancient starlight, the faint resonance of that first awakening still hums within the atoms of our being, reminding us that we are made of echoes, and that silence was never truly empty.
The beginning was not an explosion in the way we imagine, not a burst of fire in empty space, but the sudden expansion of space itself, stretching from nothing into everything. The universe inhaled, and with that first breath, existence began to move. In the smallest fraction of a second, time unfolded, and energy found shape. What had been infinite stillness became infinite motion. The first light did not yet shine, but the first heat radiated outward, an invisible wave of transformation. This was not chaos, it was the first rhythm, the first vibration, the breath of the beginning. In that newborn cosmos, the temperature was beyond comprehension, billions of degrees, a fire that filled everything yet burned nowhere. Matter did not yet exist as we know it. There were only particles of pure energy, flickering in and out of form, colliding, merging, and separating in a dance of raw creation. Space itself was expanding faster than light, carrying these particles with it, stretching them thin. There was no center, no edge, no direction. Every point was the beginning, every movement part of the same breath. The universe was not exploding into something. It was unfolding into itself. For a moment, so brief that it defies description, the expansion settled into a kind of pulse. Temperature cooled enough for matter to emerge. Protons, electrons, neutrinos, and light began to coexist in a hot plasma sea. The cosmos was dense and glowing, filled with energy that could not yet escape. Light and matter were bound together in a brilliant fog, opaque and restless. The sound of this world was not silence, but vibration. Pressure waves rippled through the young universe, compressing and expanding the plasma like the resonance of a vast, cosmic drum. The universe was breathing, and that breath had a frequency. Scientists call these ripples baryon acoustic oscillations, the echoes of pressure moving through primordial matter. If we could have listened, we would have heard deep, thunderous tones, notes that rolled not through air, but through space itself. The universe was singing in wavelengths of hundreds of thousands of light years, its music inaudible to our senses, but woven into everything that would come. This was the sound of structure being born. Where waves converged, matter gathered. Where they diverged, emptiness took hold. Galaxies, stars, and worlds would one day trace the rhythm of that first music. As the universe continued to expand, it cooled. After about 380,000 years, the temperature dropped enough for light to break free. Electrons joined with protons to form hydrogen atoms, and suddenly the universe became transparent. Light could finally travel without being scattered. The fog cleared. The first true illumination of space had begun, and the sound of the cosmos changed. What had been a dense roar softened into a whisper, the great exhalation that still hums faintly in the background of the sky. Today, we call that faint whisper the cosmic microwave background, the oldest light in existence, the echo of that first breath. It surrounds us, passing through us constantly, silent to our ears, but measurable by delicate instruments. To scientists, it is a map of the infant universe. To poets, it is the lullaby of creation, still playing after billions of years. Every photon of that ancient radiation carries the memory of expansion, the fingerprint of the first vibration that rippled through all things. The universe, in its earliest moments, left behind a sound that never stopped. To imagine this breath is to glimpse the unity between science and wonder. The Big Bang is often described as an explosion, but it was more like the beginning of a heartbeat. Expansion was the systole, cooling the diastole. With each cycle, the universe grew larger, calmer, more structured. Gravity began to sculpt the patterns left by the first sound waves, drawing matter into filaments and clusters. Even now, billions of years later, galaxies form along those same ancient lines, like notes following a hidden melody. The breath of the beginning has not ceased. It has only slowed, deepened, become the rhythm of all existence. Somewhere within this great unfolding, time began to feel its own direction. Past and future separated. Cause began to follow effect. And within that flow, meaning began to take shape, not yet conscious, but implicit in the motion. The universe was learning how to listen to itself through its own structure, how to record memory in matter and energy. Each wave of expansion was a phrase in a language too vast for words, a pattern that would one day make comprehension possible. The cosmic breath was not just physics, it was the foundation of awareness. We are part of that same exhalation. Every atom in the human body once floated in that ancient plasma, vibrating with the first sound. The breath that began the universe still moves through us as energy, as heartbeat, as thought. When we breathe, we are reenacting the oldest rhythm in existence. When we rest, the slow drift of our consciousness mirrors the cooling of the cosmos. And when we listen to silence, we are listening to the faint memory of that first expansion, the moment when stillness became motion, when nothing learned to speak. To think of it this way changes the meaning of time. The Big Bang was not just long ago. It is happening still, its effects rippling endlessly outward. Every second that passes is another echo of that original vibration. The sound of creation did not fade. It transformed into structure, into gravity, into life. The universe is still breathing, and we are the tiny moments of awareness within that breath, the soft inhalations of a cosmos that once whispered itself into being. The breath of the beginning is not over. It is what allows us to exist, to wonder, to listen for the echoes of that first divine exhalation that gave rise to all that is. Ripples traveled across the newborn universe, spreading outward through space as waves in an infinite ocean. They were not waves in water, nor vibrations through air, but oscillations in matter and energy, minute fluctuations in density that would one day shape the structure of everything. These primordial ripples carried the blueprint of existence, guiding where matter would gather and where emptiness would dominate. The universe, still young and restless, was learning to organize itself. Even in the absence of observers, it was writing a story in waves, each fluctuation a subtle punctuation in the sentence of creation. The cosmic microwave background, the afterglow of the first breath, records these ripples as faint variations in temperature. These differences were tiny, barely 1 part in 100,000, yet they contained all that would follow. Galaxies, stars, and planets would emerge along the ridges and valleys created by these early undulations. The universe was, in a sense, composing its first music, an intricate, slow symphony in which the instruments were particles, and the notes were gravitational potentials. It is remarkable to consider that every spiral galaxy, every cluster of stars, owes its shape to the soft hum of these earliest echoes, waves that began when time itself was just learning to flow. These ripples remind us that the cosmos is not a random scattering of matter. There is rhythm in creation, a hidden order beneath apparent chaos. Gravity began to amplify the fluctuations, drawing together the densest regions into clumps that would eventually ignite as stars. Where the ripples were shallow, space remained empty, forming the vast voids that stretch across the observable universe. The first structures were simple, yet within them lay the potential for complexity beyond imagining. The universe was teaching itself the language of form, using nothing more than pressure, energy, and the subtle push and pull of matter. Even the concept of time felt different in those earliest moments. In the dense plasma, light could not travel freely, and interactions occurred at speeds dictated by local conditions, not by the familiar flow we experience now. Space expanded rapidly, stretching the ripples into larger scales, smoothing some features while amplifying others. These processes, subtle yet profound, ensured that the universe would not be uniform but rich in diversity. Patterns emerged, delicate and precise, as if the cosmos were composing a melody in slow motion, one note echoing another across vast distances. As the universe cooled, atoms formed and photons began to move unimpeded, carrying the imprint of these ancient oscillations. This release of light transformed the ripples into a visible record, a map of the early universe frozen in time. Modern astronomers, peering through telescopes and interpreting faint signals, can reconstruct this cosmic song, revealing the blueprint from which all galaxies would arise. It is humbling to realize that the vast, structured universe we inhabit emerged from variations so minute that they could almost have been dismissed as insignificant. Yet, significance is measured not by size, but by consequence. The gentle waves that once rippled through the early cosmos shaped everything we now call home. The ripples also illustrate a subtle paradox, that motion and stillness coexist in creation. The waves required space to move, yet they were defined by the quiet between them, the regions of emptiness that allowed movement to be perceptible. In this way, the universe was learning to balance energy and void, sound and silence, density and dispersion. Without contrast, the melody could not exist. The cosmos was both observer and performer, vibrating within itself before consciousness emerged to interpret it. Every galaxy, every cluster, every star carries within it the faint signature of those first oscillations, a hidden rhythm that continues to echo across time and space. To consider these ripples is to expand one's sense of scale. They stretched across millions of light years, yet they originated from the tiniest fluctuations in density. Each wave, imperceptible to any eye at the time, held the potential for complexity. When regions became dense enough, stars ignited, their fusion processes adding new vibrations to the cosmic symphony. The universe's first music, once a simple oscillation, became richer and more layered with the emergence of light, heat, and matter. It was a melody that would evolve over billions of years, eventually forming the orchestra of galaxies, planets, and life. We, as observers, are attuned to these echoes only because the universe allows it. Our instruments capture the faint signals left behind, translating them into maps, graphs, and images. Yet beyond measurement lies a poetic truth, that all of this, our existence, our observations, even our consciousness, is bound to the rhythm established in those first moments. The ripples across eternity were not just physical phenomena. They were the universe learning to know itself, to organize chaos into order, to create a pattern that could eventually be understood. In listening, we participate in a dialogue that began long before there was an eye to hear it. These cosmic ripples also evoke a profound sense of humility. The vastness of the universe, measured in billions of light years, is a reminder that we inhabit only a tiny corner of creation. Yet in that corner, we can perceive the echo of the first vibrations, glimpsing the laws that govern everything from subatomic particles to the motion of galaxies. There is a quiet majesty in this realization, that something so vast and ancient can leave a trace that reaches across time, that the smallest fluctuation can give rise to the grandest structure. It is a testament to the universe's patience and precision, the careful unfolding of existence from imperceptible ripples. Even now, as we gaze at the night sky or contemplate the structure of our galaxy, we are, in a way, listening to those first oscillations. They are encoded in the distribution of stars, in the clustering of galaxies, and in the faint glow of the cosmic microwave background. The universe continues to hum its ancient song, though the notes are stretched across billions of years. By studying these ripples, we tune our ears to a melody older than any mind, older than any life, older than time itself. It is a song of persistence, continuity, and transformation, a reminder that the universe has always been in motion, always listening, always resonating with itself. The journey of these ripples, from the earliest moments to the formation of galaxies, illustrates a truth that transcends science, that small beginnings can lead to unimaginable complexity. A tiny fluctuation, a faint vibration in an infant cosmos, became the scaffolding for stars, planets, and life. In this, we find both wonder and solace. The universe is vast and indifferent, yet its earliest movements created the conditions for consciousness, reflection, and understanding. The ripples across eternity are not just echoes of what was, but invitations to imagine what might yet be. They are the music of the cosmos, carrying the memory of its birth and the promise of its endless unfolding. When the first stars ignited, the universe learned to sing. Before this moment, light existed only as a diffuse glow, trapped within clouds of dense plasma, unable to travel far. But as gravity gathered matter into dense pockets, nuclear fusion awakened within these stellar furnaces. Hydrogen atoms fused into helium, releasing energy in a slow, steady heartbeat. Each star became a living instrument, resonating with vibrations that would ripple through the fabric of spacetime. These early stars were not merely points of light. They were the first conscious actors in the cosmic symphony, their very existence adding depth, texture, and complexity to the universe's emerging melody. The process of star formation itself carries a subtle rhythm. Clouds of gas and dust collapse under their own gravity, spinning and contracting, compressing matter into increasingly dense cores. As the core temperature rises, pressure builds until fusion ignites, releasing energy in an invisible chorus. This is not a static phenomenon. It is pulsating, dynamic, alive with vibrations that travel through surrounding gas and dust. These oscillations, imperceptible to human ears, are measurable today with sophisticated instruments, revealing patterns that repeat across the galaxy. Even without consciousness, the stars are capable of producing resonance, a music of physics that predates awareness but echoes through all subsequent life. The hum of a star is subtle, a soft oscillation born of internal convection and energy release. A star may quiver, expand, and contract in rhythms that vary over days, months, or centuries. In essence, each star is singing its own song, unique yet harmonizing with the cosmic orchestra. These stellar vibrations influence the clouds of matter that surround them, shaping the birth of planets and the distribution of elements. The universe, through these stars, begins to compose a more intricate melody, one that combines the echo of its earliest ripples with the new, complex tones of nuclear fusion. This is the music that will eventually give rise to life, a song encoded in energy, matter, and time. Light from these early stars carries both illumination and resonance. Photons travel across the void, interacting with gas clouds and dust, pushing, heating, and shaping the medium. Even the tiniest particles respond to the energy, vibrating in ways that echo the star's internal rhythm. The cosmos becomes a responsive system, an environment that listens and reacts, translating nuclear energy into subtle motion and pattern. Through this interplay, the universe evolves not merely through chance, but through a delicate choreography of vibration, pressure, and gravity. Every star adds a new instrument, and the song becomes richer, more complex, more textured. Some stars, particularly massive ones, end their lives in spectacular explosions, supernovae. These events are violent yet transformative, scattering heavy elements into the surrounding space. Iron, carbon, oxygen, and other atoms, forged in the heart of the star, are released to seed new stars and planets. The shock waves of supernovae send ripples through the cosmos, adding new frequencies to the universal song. It is a cycle of creation and destruction, rhythm and resonance, where even death contributes to the music of existence. The universe is learning not only to sing, but to evolve its composition, layering complexity over simplicity, harmony over chaos. The resonance of stars is not limited to physical vibrations. It is also encoded in the patterns they create across the universe. Star clusters, nebulae, and galaxies form along paths influenced by gravity and the distribution of matter. These large-scale structures mirror the oscillations of the earliest ripples and the subtler quivers of stellar vibrations. In a sense, the universe is translating the music of the stars into geometry, producing a visual and structural symphony that can be read by those who know how to listen. Even the most distant galaxies carry the faint echoes of these early melodies, connecting the microcosm of a single star to the macrocosm of the universe itself. We are only beginning to understand the poetry of these stellar vibrations. Helioseismology, the study of sunquakes and oscillations in our own star, reveals a complex system of waves that traverse the solar interior. These waves carry information about the star's structure and evolution, allowing us to hear its internal processes. Extrapolate this to the countless stars scattered across the universe, and the scale of the cosmic symphony becomes staggering. Each star contributes its own melody, yet all are woven into a collective resonance that has persisted since the first ignition of nuclear fire. The universe, in singing, is creating a memory of itself. This music of stars has consequences beyond physics. The vibrations influence planet formation, climate stability, and the conditions necessary for life. The timing and intensity of fusion, the distribution of elements, and the dynamics of stellar clusters all shape the environments where planets can form. In subtle ways, the rhythm of a star guides the emergence of worlds capable of listening, sensing, and eventually reflecting the universe's song. Life itself is, in part, a consequence of these stellar vibrations, a response to patterns established billions of years before any observer existed. Even today, the stars continue to hum. Our instruments can detect stellar oscillations, translating them into sound for human perception. We can hear the quivers of distant suns, the heartbeat of our own, and trace these vibrations back to the earliest rhythms of creation. In listening, we become participants in the cosmic symphony, aligning our consciousness with the vast, ancient music of the universe. Every twinkling point in the night sky is more than a star. It is a note, a pulse, a reminder that the cosmos has been singing long before we were capable of hearing, and it will continue long after we are gone. To contemplate the song of stars is to recognize the continuity between the physical and the poetic. Science allows us to measure, quantify, and predict, yet the essence of stellar resonance is also deeply emotional. It evokes awe, wonder, and reflection, connecting us to the universe not only through knowledge, but through participation. The stars teach us that music is not merely sound, but vibration, pattern, and structure, a principle that underlies everything from the smallest particle to the largest galactic cluster. In understanding their song, we begin to hear the echoes of our own place within the vast, unfolding melody of existence. Stars, in their patient ignition and subtle oscillation, are the first conscious notes in a universe that began with silence. They bring the hum of life to the dark, empty spaces between galaxies, and their vibrations set the stage for all complexity that will follow. From the first quiver of matter to the intricate fusion of elements in stellar cores, the cosmos is composing a melody that spans billions of years. And in this composition, the listener, whether a conscious mind or the universe itself, can trace the path from the first echo to the elaborate symphony of light, motion, and resonance that defines existence. From the first flicker of stars, the universe began to find its rhythm, and with rhythm came pattern, and with pattern came light. Light, though invisible in its earliest moments, carried with it the blueprint of structure, the subtle influence of energy, and the cadence of matter. It moved through space not in chaotic bursts, but with order, bending, stretching, and interacting with everything it touched. In the early universe, light was not merely illumination. It was the messenger of balance, the first means by which energy could shape, refine, and communicate with the expanding cosmos. Each photon was a note in an unfolding symphony, traveling vast distances, carrying the resonance of creation across the emptiness. The rhythm of light intertwined with the motion of matter, producing harmony where once there had been only turbulence. Radiation pressure pushed against gas clouds, slowing some collapses and accelerating others. Gravity pulled at the densest regions, drawing them together into swirling formations. The universe was no longer a simple expanse of energy. It was a complex interplay, a dance of opposing forces seeking equilibrium. Light, in its relentless travel, became a conductor of this cosmic choreography, synchronizing expansion with contraction, density with void, chaos with order. In every glimmer and every shadow, the cosmos found its tempo. As galaxies formed and stars continued to hum, the universe's music became richer. Patterns emerged not by chance, but through the interaction of energy, matter, and vibration. Spiral arms, clusters, filaments, and voids traced the invisible score laid down by the earliest oscillations and the subtle pulse of light. Each structure echoed the rhythms of the initial ripples, translating primordial fluctuations into form and movement. The universe, in this sense, was self-aware, not in consciousness, but in the expression of patterns that could carry memory, influence, and eventual life. Light was the medium of this memory, illuminating paths that matter could follow, creating coherence in a once unformed expanse. The interplay of light and matter also gave rise to contrast, a vital element of rhythm. Dark regions between stars and galaxies allowed the luminous to shine, just as pauses in music give meaning to notes. Without these contrasts, there would be no perception, no sense of progression, no sense of pattern. Light highlighted, shadow defined, and the dance of visibility and obscurity created a universe both comprehensible and sublime. In this tension between illumination and emptiness, the cosmos discovered its own voice, a subtle song carried on the speed of photons, bridging vast distances and billions of years in a continuous dialogue. The rhythm of light extends beyond visual beauty. It is fundamentally tied to the evolution of complexity. Photons interact with atoms, providing energy that drives chemical reactions, heat, and the conditions necessary for planets to form. Stars, guided by the flow of light and the pressure of radiation, evolve in cycles that release heavier elements into space. These elements become the building blocks of planets, oceans, atmospheres, and eventually, life itself. Light is not merely a passive presence in this narrative. It is an active participant in shaping conditions, establishing patterns, and enabling the emergence of awareness. Its rhythm is the hidden pulse that structures existence at every scale. Time itself begins to gain meaning through the propagation of light. The finite speed at which it travels allows sequences to unfold, causality to emerge, and structures to form. Light is both messenger and measure, carrying information from one region of space to another, allowing interactions to occur in a coherent manner. Without this steady transmission, the universe would remain a jumble of matter and energy, lacking continuity. It is through the regulated passage of light that the universe's rhythm is maintained, the melody preserved, and the potential for order realized. In its movement, we see the heartbeat of creation itself. This rhythmic quality of light can also be observed in more subtle phenomena, such as the oscillations of photons in the early universe, the interplay of radiation with gas clouds, and the emergence of cosmic background radiation. Even the faintest afterglow of the first photons carries information about density, temperature, and motion, encoding a record of processes that occurred billions of years ago. Every particle that interacts with light becomes part of this cosmic resonance, absorbing, reflecting, or scattering energy in ways that perpetuate the universe's ongoing symphony. The pattern established by these interactions endures, forming the invisible scaffolding upon which galaxies, stars, and life itself will be built. The meditative aspect of this rhythm is profound. As light travels across the universe, it connects distant regions, bridging past and future, near and far. It carries the memory of creation, the signature of events that occurred before time was measured in seconds or centuries. To contemplate the journey of a photon is to step into an almost spiritual awareness. Each beam is an echo of the universe's earliest moments, a thread that links all existence into a coherent, vibrating whole. Even in silence, the movement of light preserves the music of creation, a song without sound, a rhythm without percussion, yet as vital as any heartbeat. As the cosmos matured, light found its place in the ongoing orchestration of structure and motion. Galaxies twirled, stars pulsed, and nebulae drifted, all guided in part by the subtle influence of radiation. Planets formed, atmospheres emerged, and the seeds of life began to stir in sheltered environments. The rhythm of light was both a backdrop and an active participant, orchestrating the interplay between energy and matter, shaping conditions, and establishing the cycles that would eventually enable consciousness. The universe, through light, had discovered a mechanism for coherence, continuity, and resonance, a medium by which its echo could travel across the vastness of space and time. Finally, this rhythm extends to our perception of existence. Every beam of sunlight, every distant starlight, every glimmer in the night sky is part of this ongoing pulse. In observing light, we participate in the ancient cadence of the universe, attuning ourselves to the subtle vibrations that have persisted since the cosmos first exhaled. The universe is not static, it continues to move, expand, and resonate, and through light, we can sense its song. It is a music without sound, a rhythm without end, a pattern that reminds us that order can emerge from chaos, that harmony can arise from turbulence, and that the cosmos, in all its immensity, has always been learning to hear itself. Out of the vast expanse of space, amid swirling clouds of gas and the remnants of ancient stars, a small blue world took shape. Earth, unlike anything around it, began to gather the conditions necessary for listening, not in the human sense, not yet, but in the subtle, responsive way that matter and energy can interact. Its surface cooled, forming oceans, mountains, and valleys. Its atmosphere thickened, carrying winds that whispered across its continents and clouds that shifted in gentle rhythms. Even in its infancy, the planet was a resonant system, vibrating with the echoes of cosmic events that had occurred billions of years earlier. It was a world poised to transform subtle energy into perception. The early Earth was turbulent, yet it contained patterns that would endure. Volcanoes erupted with immense pressure, sending shockwaves through the crust and atmosphere. Oceans surged and receded with tidal forces, responding to the pull of a young moon. These early movements were not random. They were rhythmic interactions that shaped the environment, laying the groundwork for stability amid chaos. Even before life emerged, the planet itself seemed to have a pulse, a cadence set by gravity, rotation, and the circulation of heat. Every tremor, every wave, every gust of wind contributed to a subtle hum that was the first expression of the planet's own resonance. Within this dynamic world, chemistry began to take form. Elements forged in stars, scattered across the cosmos by ancient supernovae, combined in complex ways within oceans, minerals, and the atmosphere. These reactions were not guided by consciousness, yet they exhibited a kind of emergent responsiveness. Molecules formed, dissolved, recombined, and began to carry the potential for complexity. The Earth, in effect, became a listener to its own processes, responding to energy, heat, and motion in ways that would eventually make life possible. Its vibrations, chemical, thermal, mechanical, were the subtle echoes of the universe, refracted through the medium of a young planet. The formation of oceans was particularly significant. Water has the remarkable ability to carry energy, to transmit vibrations, and to mediate chemical reactions. Waves sloshing against the shores, tides rising and falling with celestial rhythms, currents flowing across vast distances, all contributed to a subtle pulse that would influence the earliest life forms. Within the depths, thermal vents provided both heat and chemical gradients, creating localized environments that responded to changes in the wider planetary system. In these dynamic settings, the planet itself seemed to be speaking, offering cues and patterns that would guide the emergence of life. The ocean was Earth's first instrument, and it began to play in silence. Earth's atmosphere, too, became a medium for resonance. Winds stirred across landscapes, carrying the energy of the sun, the pressure of rising and falling air, and the faint vibrations of the planetary crust. Thunder rumbled in response to electrical imbalances, lightning crackled and sparked, and clouds shifted in organized patterns. These processes created a symphony of motion that was both predictable and endlessly variable. The young planet had the capacity to hear itself through the interaction of forces, translating energy into motion, motion into pattern, and pattern into the conditions necessary for the next phase of evolution. Gravity played a central role in this early resonance. The moon, newly formed from a cosmic collision, exerted tidal forces that shaped the oceans and influenced the rotation of the planet. The delicate interaction between Earth and its satellite created regularity in a world otherwise dominated by chaos. Day and night cycles emerged. Seasons came to be, and the predictable movement of celestial bodies set a temporal framework that life would later adopt. The planet was not conscious, but in its rotation, its tides, and its orbit, it demonstrated an innate capacity for rhythm and response, preparing the stage for beings capable of perceiving these patterns. Even before life, Earth's crust carried a subtle memory of these processes. Tectonic activity sent shock waves through continents, lifting mountains and opening valleys. Rocks and minerals, formed under immense pressure, vibrated in response to seismic forces. Magma flowed and cooled, storing energy that could later be released in quakes and eruptions. Every movement echoed the forces of formation and expansion, a silent record of the interplay between the planet and the cosmos. Earth, in this sense, was not passive. It was a resonant participant in the unfolding story of the universe, capable of responding to external and internal stimuli in ways that would later make life possible. The potential for perception began in subtle ways. Certain environments on Earth were self-sustaining, maintaining temperature, chemical balance, and energy flow in localized systems. These pockets of stability allowed molecules to interact repeatedly, setting up cycles of reaction and response. In these cycles, Earth was, in effect, listening to itself, transmitting feedback that shaped the path of complexity. The planet's physical properties, rotation, mass, composition, atmosphere, and hydrosphere, combined to produce a network of responses that resonated through its structure. It was a stage set for the eventual emergence of living beings that could consciously interpret these rhythms. By the time the first simple life forms appeared, Earth had become an instrument of cosmic resonance. Its oceans, winds, crust, and atmosphere provided a medium through which energy and vibration could flow, a system capable of responding to both internal and external stimuli. The planet itself had already learned the subtle language of cause and effect, motion and reaction, rhythm and pattern. In its vast silent processes, Earth mirrored the universe's own early oscillations, offering a continuity from the birth of galaxies to the rise of life. The tiny blue world was ready to transform vibration into perception, motion into awareness, and energy into the beginnings of listening. To contemplate this is to recognize that our world is not merely a backdrop for life, but a participant in the dialogue of the cosmos. Every wave, wind, and tremor carries a history that stretches back to the first echoes of creation. Earth listens and responds, transmitting the rhythms of stars, galaxies, and cosmic ripples into the environments that nurture life. In this sense, our planet is the first audience of the universe's song, a receptive medium that absorbs and reflects the primordial vibrations. The stage was set, the instruments tuned, and the first listeners were about to emerge from the silence of oceans and the hum of the land. Within the vast expanse of Earth's early oceans, a pulse began that would echo through the eons. The water itself became a medium of subtle vibration, carrying energy from currents, tides, and thermal gradients across immense distances. Waves rose and fell with a steady rhythm, interacting with coastlines, seafloors, and underwater formations. Even in the absence of life, the oceans were alive with movement, a slow, measured heartbeat that responded to the forces of the planet and the pull of celestial bodies. This pulse was more than physical motion. It was a carrier of resonance, a medium through which the earliest interactions of matter and energy could unfold. Tides, drawn by the gravitational pull of the moon, created cyclical patterns that repeated across days and months. These rhythms were precise, yet flexible, adapting to the contours of coastlines and the varying depth of the oceans. In these movements, we can perceive the first structured repetition in Earth's environment, a pattern that life would later adopt, respond to, and incorporate into its own rhythms. The rise and fall of tides was an early expression of temporal regularity, a natural metronome for emerging complexity. linking the motions of a distant satellite to the pulse of a living planet. Beneath the surface, thermal vents and hydrothermal systems contributed their own vibrational symphony. Superheated water and mineral-rich fluids surged upward, interacting with cooler currents to create turbulence and eddies. These localized pulses were irregular yet patterned, introducing variation into the broader rhythm of the oceans. Within these turbulent zones, chemical gradients emerged, fostering conditions suitable for the earliest biochemical reactions. In a sense, the oceans were not only moving, but communicating, transmitting energy and facilitating interactions that would set the stage for the origin of life. The ocean's vibrations extended beyond their immediate boundaries. Waves propagated across vast stretches, transferring energy from one region to another. Underwater pressure waves, generated by shifts in the crust or by the rhythmic movement of water itself, transmitted subtle pulses that could influence the distribution of sediments and the formation of structures along the seafloor. In this way, the oceans acted as a resonant system, amplifying certain frequencies, damping others, and transmitting energy across large distances. The early planet, in its fluid motion, was learning to carry and respond to its own vibrations, establishing a medium of interaction that life would eventually inhabit. Even the smallest features of the oceans contributed to this pulse. The rise and fall of ripples against ancient shores, the gentle collision of currents with underwater ridges, the eddies swirling around emerging islands, each created micro-vibrations that propagated through the water. These minor fluctuations, imperceptible on a planetary scale, nonetheless contributed to the overall rhythm, adding texture and complexity to the ocean's movement. Together, these forces created a dynamic environment in which energy, matter, and motion were intertwined, a network of oscillations that would underpin biological development. The chemistry of water itself amplified this resonance. Dissolved salts, minerals, and gases interacted with thermal energy and movement to produce subtle chemical oscillations. Reactions occurred in cycles, influenced by temperature gradients, pressure differences, and the rhythmic rise and fall of tides. These cycles became the earliest forms of natural feedback, a way for the oceans to listen to their own dynamics. Within this feedback, patterns emerged that would influence the formation of early organic molecules, providing a stable yet dynamic environment for the processes that would give rise to life. Currents, both surface and deep, further contributed to the ocean's pulse. Driven by differences in temperature, salinity, and pressure, they moved with a predictable flow, yet introduced variability as they encountered land masses, underwater formations, and other currents. This circulation distributed energy, heat, and nutrients, creating a complex web of interaction that linked distant regions of the planet. The oceans became not just a passive medium, but an active participant in shaping the conditions necessary for the origin and evolution of life. Their movement was a form of planetary awareness, a resonance that could respond to internal and external forces in subtle yet meaningful ways. Life began to emerge in these oceans, attuned to the rhythms that the planet had established. Microscopic organisms, protocells, and early multicellular life forms sensed and responded to vibrations in their environment. Currents delivered nutrients, tides created cycles of exposure and submersion, and thermal vents provided localized energy sources. The ocean's pulse became a guide for behavior, a template for adaptation, and a channel through which energy and information could flow. In responding to these vibrations, life became a continuation of the planet's own resonance, an extension of the ocean's song. Even as life grew more complex, the oceans maintained their central role in transmitting subtle pulses across the globe. Seasonal changes in temperature and circulation introduced long-term rhythms that shaped migration, reproduction, and ecological interactions. Storms and wind-driven waves added irregular but patterned energy, introducing variation that prompted adaptation and evolution. The oceans were simultaneously stable and dynamic, a medium that allowed continuity while fostering change. Their pulse was the heartbeat of the planet, a steady rhythm that connected the smallest microorganisms to the broader cycles of Earth systems. The meditative quality of the ocean's resonance is striking when considered across geological time. Billions of years of waves, currents, tides, and thermal flows created a continuous vibration, a planetary memory that would influence every stage of life's development. Even the faintest disturbance could ripple outward, echoing through the marine environment and shaping the conditions for adaptation and growth. The oceans, in this way, were both audience and participant in the unfolding story of life, transmitting and responding to vibrations that had traveled from the earliest stars through planetary formation and into the rhythm of Earth itself. To inhabit this perspective is to recognize the profound connection between water, vibration, and life. The oceans are not merely containers for living organisms. They are active participants in the transmission of energy, the regulation of cycles, and the orchestration of rhythm on a planetary scale. Every wave, every current, every tidal oscillation is part of a larger pulse, a resonance that links the planet to the universe itself. In listening to this pulse, even imaginatively, we become aware of the continuity of energy from the cosmos to the depths of the sea, tracing a path from the first cosmic ripples to the earliest breaths of life in Earth's oceans. The Earth, having established its pulse through oceans, winds, and tides, became a cradle for the first delicate sparks of life. Within the protective embrace of water, molecules collided, combined, and reorganized in patterns that hinted at purpose. Amino acids, lipids, and nucleotides, the building blocks of life, began to assemble in ways that were influenced by the rhythms of the planet itself. The ocean's vibrations, tides, and thermal currents were more than background phenomena. They provided a framework, a metronome, by which chemical interactions could occur repeatedly, increasing the likelihood of complex structures emerging. Life did not begin in silence. It began listening to the subtle cadences of its environment. The earliest organisms were microscopic and invisible, yet they were sensitive to the pulses around them. They responded to temperature fluctuations, chemical gradients, and the gentle motion of water. In doing so, they became extensions of the planetary rhythm, moving, growing, and reproducing in synchrony with the oscillations of tides and currents. The boundary between organism and environment was porous. Energy flowed freely between them, and feedback loops formed. Life was not separate from Earth's vibration. It was a continuation of it, a living echo of the planet's own pulse. Photosynthesis emerged as a profound turning point in this symphony of life. Organisms capable of capturing light and converting it into chemical energy transformed the environment. The light that had been traveling across space for billions of years, the echo of distant stars and the rhythm of nuclear fusion, was now harnessed by life itself. With this process, organisms began to interact directly with the energy of the cosmos, converting photons into usable energy and releasing oxygen as a byproduct. The planet's atmosphere slowly began to change, shifting in composition and opening new possibilities for life. Light had become both a conductor and a collaborator, linking distant stars to the metabolism of the smallest cells. As life diversified, so did its rhythms. Some organisms followed daily cycles, responding to the rotation of the Earth, the rise and fall of the sun, and the predictable alternation of light and dark. Others adapted to longer cycles, influenced by tides, lunar phases, or seasonal shifts. These rhythms were not conscious choices. They were responses to energy patterns established billions of years earlier. Life had become a translator, converting environmental vibrations into behavior, survival strategies, and reproductive timing. In this way, Earth's original pulse, inherited from cosmic forces, had become the template for biological rhythm. The development of multicellular life added new layers of complexity to the planetary symphony. Groups of cells began to coordinate, creating organisms capable of more sophisticated responses to environmental stimuli. Motion, feeding, and reproductive cycles became synchronized with planetary and stellar rhythms. The oceans, still the dominant medium of energy and movement, carried signals across vast distances, transmitting information and facilitating interaction. Even the microscopic interactions of cells were shaped by tidal and thermal oscillations, demonstrating that the influence of planetary rhythm penetrated life at every scale. The emergence of neural networks in more complex organisms allowed life to sense, process, and respond to vibrations in new ways. Sensory systems evolved to detect changes in light, pressure, temperature, and chemical composition. The world became more than a backdrop. It became a dynamic environment that could be interpreted, predicted, and anticipated. Life began to internalize rhythm, developing memory and anticipation of recurring patterns. This marked the beginning of perception, a subtle form of listening that was both reactive and predictive, linking organisms to the deep time of Earth's oscillations and the ongoing resonance of the cosmos. As terrestrial ecosystems emerged, life's interaction with planetary rhythms became increasingly intricate. Plants adapted to the cycles of sunlight, precipitation, and seasonal variation. Animals developed circadian rhythms, migration patterns, and reproductive cycles synchronized with environmental cues. The interdependence of species created feedback loops that reinforced and amplified the planet's pulse. Life was no longer passively following Earth's rhythm. It was shaping it, influencing climate, atmospheric composition, and even geological processes. In this partnership, the planet and its life forms became co-authors of a living symphony, a collaboration that spans billions of years and continues to this day. The evolution of sensory perception allowed organisms to respond not only to immediate stimuli, but also to subtle environmental changes, translating oscillations into survival strategies. Vibrations in the ground could signal the approach of predators, currents in the water could guide movement and foraging, and variations in light could indicate time and season. Life was attuned to these pulses in ways that predated consciousness, yet laid the groundwork for future awareness. In sensing these rhythms, organisms became participants in the echo of creation, interacting with the vibrations of the planet and, indirectly, the universe itself. Even in the simplest forms of life, the legacy of cosmic and planetary oscillations was evident. From the rise and fall of microbial populations with tidal cycles to the internal chemical rhythms of single-celled organisms, life carried the imprint of the universe's earliest vibrations. Each heartbeat, each growth cycle, and each cellular oscillation was an extension of rhythms that began in the motion of matter, the pulse of light, and the vibrations of the forming Earth. Life had become both listener and performer, translating the silent music of the planet into action, adaptation, and evolution. The emergence of ecosystems amplified the complexity of this interaction. Food webs, predator-prey relationships, and nutrient cycles created nested rhythms, with each component responding to the vibrations of others. Energy flowed in oscillating patterns through these networks, maintaining stability while allowing adaptability. The planet, oceans, and life had become a single resonant system, with vibrations cascading through scales from molecules to continents. In this intricate interplay, the echo of the universe's first pulse persisted, guiding the unfolding story of life through rhythms that are at once physical, chemical, and biological. Through these processes, the Earth became a living, resonant entity, its pulse intertwined with the motions of the cosmos. Life, in its earliest forms, was attuned to these oscillations, responding to subtle cues, harnessing energy, and perpetuating rhythms that had begun billions of years before. The oceans, tides, winds, and light continued to provide a metronome for development, while the organisms themselves began to influence and amplify these patterns. In this grand tapestry, the legacy of cosmic echoes is embedded in every cellular reaction, every wave, and every cycle of the planet's living systems, a reminder that life is the continuation of the universe listening to itself. As life continued to flourish on Earth, a subtle awareness of rhythm began to emerge, encoded not in thought, but in the natural cycles of being. Organisms had long responded to tides, light, temperature, and seasonal change, but with increasing complexity, these responses became anticipatory. Circadian rhythms synchronized with the rising and setting of the sun, influencing feeding, movement, and reproduction. Lunar cycles guided tidal behaviors. Seasonal shifts dictated migration, dormancy, and flowering. These patterns were more than survival mechanisms. They were the first form of temporal listening, a sensitivity to the larger rhythms of a planet that had itself inherited the echoes of cosmic vibrations. The intricate dance of ecosystems deepened this resonance. Predators and prey, plants and pollinators, herbivores and decomposers, all responded to cycles established by the environment. Energy flowed through these networks in oscillating patterns, creating feedback loops that reinforced stability and facilitated adaptation. Life became a system of nested rhythms, each layer interacting with the others, amplifying some pulses while dampening others. In this way, the planet itself acted as a conductor, orchestrating the countless interactions that would eventually form the intricate music of ecological balance. The Earth had become both instrument and audience, its vibrations guiding the unfolding of life. With the rise of nervous systems, organisms gained the ability to process information from their environment in more sophisticated ways. Simple reflexes evolved into sensory processing, memory, and anticipation. Eyes, ears, and other sensory organs translated light, vibration, and chemical signals into data that could be used to navigate the world. The motion of wind, the flow of water, and the cycles of day and night were no longer mere background phenomena. They became inputs for decision-making. Life was beginning to internalize rhythm, shaping behavior according to the subtle oscillations of its environment. In this way, living beings became active participants in the echo of planetary and cosmic pulses. The development of social behavior in some species further amplified sensitivity to rhythm. Groups coordinated movement, hunting, or migration according to shared cues, creating emergent patterns that were larger than any individual. The synchronization of action and response mirrored the larger environmental oscillations, reinforcing the resonance between organism and planet. Communication, whether through visual signals, chemical pheromones, or sound, allowed organisms to transmit information about timing and behavior, expanding the scope of rhythmic awareness. In this collective listening, the legacy of cosmic vibrations was echoed and propagated through networks of life. Sound itself became a medium for interaction, long before humans existed to perceive it consciously. From the low-frequency rumblings of elephants to the songs of whales across oceans, vibrations carried information, coordinated behavior, and influenced social structure. These signals often aligned with environmental rhythms, integrating the internal pulse of the organism with the external pulse of the planet. The music of life had begun, subtle, functional, and resonant, echoing patterns established in the earliest oscillations of the universe and transmitted through the mechanics of the Earth itself. As life moved from oceans to land, the challenges of a new environment imposed additional layers of rhythmic interaction. Day and night cycles became more pronounced, seasonal variations more extreme, and interactions with weather and landscape more complex. Plants and animals adjusted to these patterns, developing behaviors, reproductive strategies, and physiological responses tuned to the cycles of light, temperature, and precipitation. These adaptations were not conscious, yet they reflected a deep attunement to the rhythms of Earth, a sensitivity inherited from the cosmic and planetary vibrations that had guided life's emergence in the oceans. Plants, in particular, displayed remarkable responsiveness to light and time. Photoreceptors allowed them to track day length, regulate flowering, and optimize energy capture. Root systems responded to moisture gradients, and leaves oriented to maximize photosynthesis, while minimizing exposure to heat or wind. Even at the level of a single organism, a network of oscillatory processes unfolded, translating environmental rhythms into internal cycles of growth, metabolism, and reproduction. In this way, the pulse of life was mirrored in countless microcosms, each attuned to larger planetary and celestial oscillations. Animals, too, developed increasingly sophisticated responses to rhythm. Migratory birds navigated using the sun, stars, and magnetic fields, coordinating movements across continents according to predictable cycles. Insects timed emergence to coincide with flowering plants, synchronizing their lives with the pulses of energy and growth in the environment. Predatory and prey species adjusted hunting, feeding, and reproduction to match fluctuations in availability, pressure, and risk. Life on land had become a vast network of temporal listening, with each species encoding and responding to oscillations that began billions of years before on a cosmic scale. Even in microscopic processes, the echo of cosmic and planetary rhythms persisted. Biochemical cycles, circadian clocks, and cellular oscillations translated external cues into internal signals, regulating metabolism, gene expression, and replication. The influence of tides, light cycles, and temperature gradients created a resonance that propagated through populations and ecosystems. Life had become a bridge between the cosmos and consciousness, translating the silent music of the universe into tangible patterns of survival, growth, and reproduction. Each organism, whether microscopic or immense, was part of a resonant continuum stretching back to the first vibrations of creation. Through these interconnected rhythms, Earth became a living, responsive system, a symphony of oscillations that linked matter, energy, and life across scales. Organisms internalized and amplified these rhythms, creating patterns that echoed cosmic origins and planetary processes. The universe's earliest ripples had traveled from the first stars, through the formation of planets, into the oceans, and finally into the complex interactions of terrestrial life. In every heartbeat, every cycle of growth, and every seasonal migration, the echo of the cosmos persisted, a reminder that life is not isolated, but an ongoing dialogue with the universe itself. With the evolution of sensory perception and complex behaviors, life on Earth began to interact with the environment in ways that were increasingly reflective of the universe's earliest rhythms. Neural networks allowed organisms to detect subtle changes in light, pressure, temperature, and chemical gradients, converting these signals into coordinated responses. Even without consciousness, life was engaging in a form of listening, translating environmental vibrations into movement, adaptation, and survival strategies. This process mirrored the universe itself. From cosmic ripples to planetary oscillations, each system responded to external forces with precision, sensitivity, and resonance. The emergence of auditory perception marked a profound expansion in life's interaction with rhythm. Vibrations in air, water, and solid substrates became more than incidental occurrences. They became carriers of information. Early animals could detect the subtlest quivers of a predator approaching, the faint pulse of flowing water, or the movement of prey in distant reaches. These signals were not conscious music, yet they contained temporal and spatial information that organisms could decode and act upon. In essence, the universe's earliest oscillations had traveled through cosmic, planetary, and biological scales, arriving as actionable guidance for living systems. Communication through sound evolved as species grew more social. Calls, clicks, songs, and other signals allowed individuals to coordinate hunting, mating, and migration. These vocalizations often aligned with environmental cycles, the rise and fall of tides, seasonal changes, and day-night transitions. Through this alignment, life demonstrated a remarkable capacity to integrate multiple layers of rhythm. The internal oscillations of organisms, the temporal patterns of ecosystems, and the planetary and cosmic forces that underlie them. Sound became a bridge between organism and environment, a medium through which life could interpret and participate in the ongoing pulse of existence. Even the most subtle vibrational cues played critical roles. Ground tremors, wind-induced rustling, and the resonance of tree trunks or water surfaces all transmitted energy across the landscape. Animals tuned their behaviors to these cues, often unconsciously, forming a network of response that amplified and propagated rhythmic signals across the environment. Predators used these vibrations to hunt, prey to avoid detection, and communities to coordinate movement. The echo of the universe's earliest ripples, once imperceptible on a cosmic scale, had now filtered through millennia of planetary and biological processes to become a tangible guide for life. The evolution of hearing also introduced the capacity for temporal prediction. Organisms could anticipate the next occurrence of a vibration or sound, synchronizing activity with environmental patterns. Circadian rhythms, seasonal migrations, and reproductive cycles were increasingly guided by auditory cues that reflected planetary and celestial oscillations. Life had learned to track the passage of time not merely through passive observation, but through active engagement with rhythmic phenomena, refining behavior to maximize survival and reproduction. In doing so, living beings became more than passive recipients of the universe's pulses. They became participants in a complex temporal dialogue. Social coordination added layers of emergent rhythm. Groups of animals, from flocks of birds to schools of fish, coordinated their movements with remarkable precision. Individual actions were influenced not only by internal timing, but by the behavior of others, creating collective oscillations that propagated through populations. These emergent rhythms often reflected underlying environmental patterns, reinforcing synchronization with the broader pulse of the planet. Life's capacity to align individual and collective behavior with environmental and cosmic oscillations illustrates the deep continuity of resonance from the birth of the universe to the dynamics of modern ecosystems. Even the oceans, sound propagated across vast distances, linking creatures separated by hundreds of kilometers. Whales, for instance, produced low-frequency calls that could traverse entire ocean basins, facilitating communication, navigation, and social cohesion. In these deep, resonant vibrations, the echoes of planetary and cosmic rhythms were embedded, traveling through water, as though carrying a memory of creation itself. Life had harnessed the physics of vibration to extend awareness across space, transforming environmental oscillations into a living, responsive network of sound and motion. The amplification of rhythm through sound also created opportunities for learning and adaptation. Repeated patterns allowed organisms to anticipate outcomes, modify behavior, and develop strategies for survival. Neural circuits evolved to encode temporal sequences, reinforcing responses to predictable oscillations in the environment. Over generations, these capacities strengthened, enhancing the ability of life to interact with increasingly complex systems. The resonance established billions of years earlier, in cosmic ripples, planetary tides, and oceanic waves, had become a guide, shaping the trajectory of evolution itself. Plants, too, responded to vibrational cues, though in different ways. Root growth, cellular signaling, and biochemical reactions could be influenced by mechanical oscillations in soil and air. Subtle vibrations from water flow, wind, or the movement of animals affected plant behavior, integrating them into the broader network of environmental resonance. Even seemingly stationary life forms participated in the pulse of the planet, attuned to oscillations that had their origin in cosmic, planetary, and ecological forces. Life as a whole had become a network of vibration-sensitive participants, responding to and propagating patterns across scales. In this unfolding complexity, the universe's first echoes found expression in living behavior. The oscillations that once shaped galaxies now guided the motion of cells, organisms, and ecosystems. Sound and vibration became the medium through which life interpreted energy and matter, responding to cycles that spanned seconds to millennia. The emergence of auditory perception represents a critical juncture. The universe, once silent and vast, had now found living interpreters capable of detecting, internalizing, and responding to its rhythms. In this dialogue between organism and environment, life became a conscious, or at least preconscious, listener, participating in a chain of resonance that stretches from the first ripples of creation to the complex symphony of Earth today. As life continued its intricate dance with Earth's rhythms, a profound development emerged: the capacity for memory and anticipation. Neural networks became increasingly sophisticated, not merely reacting to immediate stimuli, but encoding patterns over time. The rise and fall of tides, the alternation of day and night, seasonal cycles, and the migration of celestial bodies were all recorded, in a sense, within biological systems. Organisms learned to anticipate these cycles, adjusting behavior to optimize survival and reproduction. This ability to remember and predict represented a subtle form of listening, a conscious attunement to the recurring pulses of the planet and indirectly, to the echoes of the cosmos itself. In the oceans, fish and marine mammals developed migratory patterns attuned to the moon, tides, and seasonal shifts. Coral polyps synchronized spawning with lunar cycles, a delicate timing that ensured the continuation of species across generations. The memory of cycles became embedded not only in neural structures, but also in genetic and biochemical pathways, creating a biological archive of environmental rhythms. Through this integration of memory and behavior, life became a recorder of the universe's pulse, perpetuating the resonance of planetary and cosmic oscillations across time. On land, the interplay of memory and rhythm became even more pronounced. Animals tracked seasonal changes, food availability, and predator-prey interactions, adapting migration, hibernation, and reproductive timing accordingly. Birds navigated thousands of kilometers with precision, guided by the position of stars and the magnetic field, demonstrating an uncanny alignment with celestial cycles. Even insects responded to day length and temperature, synchronizing life stages with environmental conditions. Memory in all its subtle forms allowed organisms to anticipate the patterns established long before consciousness emerged, weaving individual existence into the vast tapestry of planetary and cosmic rhythm. The evolution of social structures amplified these effects. Packs, herds, flocks, and colonies relied on collective memory to navigate, forage, and reproduce. Learned behaviors and signals were shared, creating a distributed form of memory that transcended individual lifespans. Communication through vocalization, movement, or chemical signaling encoded temporal patterns, allowing groups to anticipate environmental changes with remarkable accuracy. In this way, memory and rhythm became intertwined, reinforcing the resonance between life and the world around it, and extending the echo of cosmic pulses into social and ecological networks. Memory also enabled more complex forms of adaptation. Organisms could respond not just to immediate cycles, but to subtle shifts in those cycles over years or decades. Long-lived trees sensed multi-year patterns of rainfall, temperature, and soil moisture, adjusting growth and reproduction accordingly. Predators and prey tracked population cycles, adapting strategies based on past experiences. In this manner, the Earth's pulse was internalized across scales, from individual cells to entire ecosystems, creating a continuity of resonance that bridged generations and reinforced the planet's vibratory rhythm. Even at the cellular level, molecular mechanisms acted as repositories of memory. Feedback loops, protein oscillations, and gene regulatory networks recorded temporal information, translating environmental signals into persistent patterns of behavior. Circadian clocks in organisms are one example, encoding the daily rotation of Earth into biochemical cycles that govern metabolism, sleep, and activity. These internalized rhythms connect the smallest life forms to the vast oscillations of the planet, and, by extension, the larger cosmos. Memory, in this sense, becomes a bridge, translating ancient rhythms into ongoing adaptation. The development of memory also allowed life to interact with rhythm in more anticipatory ways. Organisms could predict, rather than merely react, aligning activity with future occurrences of environmental cycles. This predictive capacity increased efficiency and survival, reinforcing the importance of resonance with planetary patterns. In a profound sense, memory transformed life from a passive responder to an active participant, capable of co-creating temporal order within the broader vibratory landscape of Earth. Sensory systems evolved in tandem with memory, enhancing the ability to detect subtle temporal patterns. The interplay of perception and recollection allowed organisms to refine behavior according to nuanced environmental cues. Predators learned the timing of prey activity. Prey anticipated predator patterns. Pollinators synchronized with plant flowering cycles. Plants adjusted to pollinator availability. Through this intricate network of memory-informed behavior, life increasingly harmonized with the rhythms of the planet, translating environmental oscillations into the timing of growth, reproduction, and survival. The role of sound and vibration in memory became more pronounced. Echoes, calls, and other auditory signals could be retained and interpreted over time, providing a temporal framework for coordination and learning. Songbirds, marine mammals, and even insects used these signals to synchronize behavior across individuals and generations. In doing so, they perpetuated not only biological rhythms, but also the memory of environmental oscillations, ensuring continuity of resonance through time. Sound became a repository of temporal knowledge, a living archive of planetary and cosmic pulse. Through these layers of memory, anticipation, and rhythmic alignment, life on Earth became deeply entwined with the vibrations of the universe. Neural, genetic, social, and ecological systems all encoded and responded to oscillations, creating a continuum that linked the earliest cosmic ripples to the complex symphony of life unfolding today. In remembering and anticipating, organisms participated in a dialogue that stretches from the birth of stars to the intricate networks of Earth itself, echoing the first sounds of creation in patterns of movement, growth, and collective resonance. With the accumulation of memory and anticipation, life on Earth began to orchestrate its responses on increasingly complex temporal scales. Neural networks, social structures, and environmental interactions converged to create a web of interdependent rhythms. Organisms were no longer simply reacting to the immediate present. They were anticipating patterns that unfolded across hours, days, seasons, and even years. The planet's pulse, shaped by tides, rotation, orbit, and climate cycles, had become a metronome, a subtle guide that informed behavior and adaptation across every layer of the biosphere. Life was now coalescing into an intricate dialogue with time itself. The forests and grasslands, shaped by cycles of growth, decay, and renewal, became arenas where rhythm was deeply embedded. Trees tracked light and moisture, opening and closing stomata in response to daily and seasonal cycles. Herbivores timed grazing and movement according to availability and predator activity. Predators, in turn, adjusted hunting patterns in response to prey behavior and environmental conditions. In these interactions, rhythm was both medium and message, a continuous feedback loop that connected individual behavior with broader ecological oscillations. Each organism was a node in a network tuned to the subtle cadence of Earth. The oceans, too, maintained their role as global conveyors of rhythm. Currents, tides, and temperature gradients transmitted oscillations across vast distances, influencing migration, reproduction, and feeding patterns. Whales, fish, plankton, and other marine organisms responded to these signals, sometimes over thousands of kilometers, following cues established by the interplay of planetary rotation, lunar influence, and thermal energy. Life in the oceans had become a living map of resonance, tracing the pathways of energy and vibration that flowed through the planet. The echoes of the universe, filtered through the formation of Earth, continued to guide movement, survival, and adaptation. Seasonal changes imposed further complexity. Organisms had to synchronize with shifts in temperature, precipitation, and food availability. Migration, hibernation, reproduction, and flowering became tightly linked to these temporal patterns. The predictive use of memory allowed species to anticipate the arrival of spring, the height of the dry season, or the periodic abundance of prey. Through these mechanisms, life encoded a sophisticated understanding of time, integrating planetary rhythms into internal cycles that aligned survival strategies with environmental reliability. This was no conscious planning, but it was a form of profound attunement to temporal oscillation. Within individual organisms, circadian rhythms integrated external cues with internal physiology. Hormonal cycles, metabolic processes, and behavioral patterns all synchronized with light and temperature cycles, forming an internal echo of planetary rhythm. These biological clocks ensured that activity was optimized for environmental conditions, conserving energy, enhancing survival, and improving reproductive success. The precision of these rhythms, honed over millions of years, reflects the deep resonance between living systems and the oscillatory forces of the planet itself. Every pulse, every beat, every biochemical oscillation was a translation of planetary time into the language of life. Social coordination added another layer of temporal complexity. Flocks of birds, herds of mammals, and colonies of insects synchronize their behavior not only with the environment, but also with each other. Collective action, facilitated by communication and shared memory, created emergent rhythms that could respond dynamically to changes in conditions. The alignment of individual and group behavior reinforced environmental patterns, amplifying the planet's pulse through networks of living beings. In this way, rhythm extended beyond individual experience, weaving together populations, ecosystems, and the biosphere into a cohesive temporal structure. Even at the microscopic level, the legacy of rhythm persisted. Cellular processes, such as protein synthesis, DNA replication, and metabolic cycles, were sensitive to environmental oscillations. Feedback loops, molecular clocks, and chemical gradients created internal harmonies that mirrored external rhythms. Life became a continuum of nested oscillations, linking molecular behavior to organismal activity, ecosystem dynamics, and planetary cycles. The echoes of cosmic and planetary vibrations were embedded in the fundamental processes of life, guiding evolution and adaptation in ways both subtle and profound. Climate cycles introduced longer-term oscillations, shaping adaptation over centuries and millennia. Glacial and interglacial periods, driven by orbital variations and solar fluctuations, imposed constraints that life learned to anticipate through generational memory. Species adapted migratory patterns, reproductive timing, and habitat use in response to these shifts, encoding resilience into populations and ecosystems. The temporal scale of response expanded as life internalized rhythms spanning from daily cycles to multi-millennial fluctuations, reflecting the deep entanglement of the biosphere with planetary dynamics. The expansion of life into new ecological niches further amplified the interplay of rhythm and adaptation. Forests, deserts, mountains, and wetlands each presented unique temporal challenges. Organisms evolved to match these rhythms, responding to the oscillations of temperature, moisture, and resource availability. Niche specialization became a form of resonance tuning, where species adjusted to the specific cadence of their environment. Life, in this sense, was a dynamic participant in planetary symphony, with each adaptation a note in the ever-unfolding composition of Earth's rhythms. The sensory sophistication of life also enhanced the capacity to detect subtle environmental cues. Changes in wind, light, pressure, vibration, and chemical gradients were continuously integrated into behavioral responses. Memory and anticipation allowed organisms to translate these cues into action, synchronizing with cycles beyond immediate perception. In this way, life functioned as a living network of temporal sensors, attuned to rhythms established long before consciousness emerged. Each organism, population, and ecosystem became an interpreter of planetary and cosmic oscillations, carrying forward the resonance of creation itself. Through these intricate networks of memory, perception, and anticipatory behavior, life had become deeply entwined with the universe's rhythms. From molecular oscillations to planetary pulses, from individual behavior to social and ecological networks, the echo of cosmic origins persisted in every living system. Earth itself, once a passive receiver of energy and motion, had become a responsive, resonant entity. Life, through its adaptation, memory, and synchronization, transformed these oscillations into a dynamic, evolving symphony, extending the first vibrations of creation into the complex, temporal architecture of the biosphere. As life on Earth became increasingly complex, the integration of rhythm, memory, and perception gave rise to behaviors that were not only reactive but creative in their expression. Organisms began to explore and manipulate the patterns around them, responding to environmental cues with flexibility and innovation. Predators refined hunting strategies based on the anticipated movement of prey. Prey evolved counter-strategies to evade detection. Pollinators and plants engaged in intricate mutualistic cycles, adjusting flowering and feeding schedules in a synchronized dance. Each interaction was a modulation of rhythm, an echo of the oscillatory patterns established by the Earth and, ultimately, the cosmos itself. With the emergence of neural sophistication, Some organisms develop the capacity to store and process information over longer periods, enabling learning and problem-solving. Memory, once a passive record of environmental patterns, became a dynamic tool for shaping future behavior. Birds learned complex song patterns, adjusting calls to social context and environmental noise. Mammals modified movement patterns to optimize energy use and survival chances. In every case, living beings were translating subtle environmental oscillations into coordinated, adaptive actions. In essence, life had become a responsive interpreter of planetary rhythms, capable of innovation while still grounded in the fundamental oscillations of the universe. The evolution of communication further amplified these capacities. Through vocalization, visual signals, chemical cues, and touch, organisms transmitted temporal information across individuals and generations. Learned behaviors, such as foraging techniques, migratory routes, and social hierarchies, were encoded into collective memory, creating emergent cultural rhythms within populations. This social transmission extended the reach of life's responsiveness, allowing synchronization over vast scales and long time frames. In doing so, life not only responded to environmental pulses, but also generated new oscillatory patterns that reverberated through ecosystems. In parallel, environmental pressures continued to refine sensitivity to rhythm. Seasonal cycles, tidal patterns, and celestial oscillations imposed selective constraints, favoring those organisms whose internal timing could align with external cues. Long-lived species developed intricate mechanisms for predicting changes in resource availability, weather, and the behavior of other species. Even transient events, such as storms or volcanic eruptions, became part of the adaptive matrix, with life responding to irregular pulses in ways that preserved continuity. These adaptations reinforced the interconnectedness of living systems with the larger temporal architecture of the planet. The development of tool use and manipulation in certain species introduced an unprecedented layer of interaction with rhythm and environment. Primates, birds, and other intelligent organisms began shaping their surroundings, altering the temporal dynamics of resources, shelter, and social interaction. By modifying physical or social environments, these organisms could influence the oscillatory patterns of others, subtly participating in the modulation of ecological rhythms. This marks an early stage in the capacity for life to become not only listener but conductor, orchestrating portions of the planetary symphony to suit adaptive goals. Even in more basic organisms, the interplay between behavior and environmental rhythm continued to produce emergent patterns. Swarming insects, schooling fish, and flocking birds exhibited collective behaviors that created large-scale oscillations in response to environmental cues. These emergent rhythms were adaptive, allowing groups to navigate, forage, and avoid predation efficiently. The patterns of collective movement mirrored, on a larger scale, the internal synchronization of cellular and organismal processes. Life was expressing resonance at multiple scales, from the microscopic to the ecological, weaving the fabric of planetary rhythm into observable phenomena. The interplay between light, vibration, and energy became increasingly central to behavioral sophistication. Organisms tracked solar and lunar cycles, responding to shifts in illumination, temperature, and gravitational influence. The anticipation of these cycles informed reproductive timing, feeding schedules, and social interactions. Even subtle environmental cues, the angle of sunlight, the sound of flowing water, the vibration of the ground, were incorporated into behavioral routines. Life had become a complex interpreter of oscillation, translating physical energy into adaptive movement, growth, and social interaction, perpetuating the echo of cosmic and planetary rhythms. As ecosystems matured, networks of feedback loops expanded in complexity. Predator-prey cycles, plant-pollinator relationships, and nutrient flows all created cascading oscillations, amplifying or dampening environmental pulses. Species adapted not only to the direct influence of external rhythms, but also to the patterns generated by other organisms, forming a multi-layered lattice of resonance. The environment itself became a collaborative participant in life's ongoing symphony, with energy and information continuously exchanged, processed, and propagated across scales. Earth's rhythms, once subtle and primordial, now underpinned a dynamic, living network of interdependent oscillations. Even the capacity for memory and learning in simple organisms contributed to the shaping of planetary resonance. Repeated behaviors, timing of movement, and social coordination produced cumulative effects that influenced the flow of energy and resources. Over generations, these behaviors became embedded in genetic, epigenetic, and cultural frameworks, creating persistent patterns that aligned life with the cycles of the planet and the broader cosmic environment. In this way, the echoes of the universe's first vibrations were encoded not only in individual organisms, but also in the collective history of ecosystems. Ultimately, the increasing complexity of life on Earth represents a continuous amplification of rhythm, memory, and resonance. From cellular oscillations to ecosystem cycles, from individual learning to collective behavior, every layer of life became a participant in the ongoing dialogue with planetary and cosmic forces. The emergence of perception, anticipation, and social coordination illustrates the deep continuity between the earliest cosmic ripples and the behaviors of organisms across time. Life had become not just a recipient of the universe's echoes, but a co-creator of a resonant, evolving symphony, one that would continue to unfold across eons. With the advent of greater cognitive complexity, life on Earth began to interact with its environment in increasingly sophisticated and reflective ways. Organisms not only responded to immediate stimuli, but also integrated past experiences and projected possible futures, creating a dynamic interplay between memory, anticipation, and action. Neural networks, sensory systems, and social structures allowed for the encoding of subtle temporal patterns, producing behaviors finely tuned to the oscillations of light, temperature, tides, and seasonal cycles. Life had become an active interpreter of the planet's rhythms, attuned to both the regularity and the unpredictability embedded in the world. In terrestrial environments, the interplay of rhythm and cognition manifested vividly. Migratory species relied on a combination of inherited instinct, learned behavior, and environmental cues to navigate vast distances. Birds followed celestial markers and magnetic fields, synchronizing flight with seasonal and daily cycles. Mammals timed breeding and feeding patterns to coincide with the availability of resources, responding not only to immediate signals, but also to anticipatory cues shaped by experience. Plants, too, displayed remarkable rhythmic sensitivity. Flowering, leafing, and growth cycles aligned with photoperiods and climate rhythms, ensuring the optimization of energy use and reproductive success. In each case, life had begun to internalize the subtle cadences of the planet, translating them into adaptive strategies. Social complexity added a further layer of resonance. Flocks, herds, and colonies coordinated actions in ways that amplified environmental rhythms. Collective memory and shared learning allowed groups to predict and adapt to changes in resource availability, predation pressure, and climatic variation. Communication, whether through sound, gesture, or chemical signaling, became a mechanism for synchronizing behavior across individuals, producing emergent patterns that reinforced ecological cycles. In this way, life extended the planetary rhythm into social and behavioral dimensions, linking individual experience to population-level resonance and amplifying the echo of Earth's oscillations. The emergence of sophisticated problem-solving and learning introduced flexibility in temporal alignment. Organisms could adjust activity in anticipation of irregular events, storms, droughts, or fluctuations in prey populations. Memory, perception, and social cues combined to generate adaptive responses that were predictive rather than purely reactive. This capacity transformed life into an active participant in the management of rhythm, capable of shaping, reinforcing, or modulating the oscillations that structured ecosystems. The planet's pulse was no longer a fixed metronome. It became a living dialogue between Earth and its inhabitants. Sensory perception played a critical role in this ongoing dialogue. Vision, audition, olfaction, and mechanosensation provided multidimensional feedback, enabling organisms to detect the faintest deviations in environmental rhythm. Birds, for example, adjusted flight and foraging behavior based on light angles and atmospheric pressure changes. Aquatic mammals navigated using sonar and waterborne vibrations, aligning movement with tidal and thermal cycles. Even plants registered vibrational cues, altering root growth and cellular signaling in response to subtle mechanical stimuli. Life, across scales and taxa, had become an interpreter of oscillation, transforming external energy into action, growth, and coordination. Memory and learning now extended across generations, creating a temporal bridge that linked individual experience with evolutionary history. Behavioral patterns, migratory routes, foraging strategies, and social norms were passed through imitation, teaching, and genetic encoding. This transmission of knowledge reinforced alignment with environmental cycles, enabling species to anticipate fluctuations on scales beyond the immediate lifetime. Through these mechanisms, the resonance established by the earliest cosmic and planetary oscillations continued to echo, shaping adaptive behavior and ecological dynamics over millennia. The interplay of rhythm, memory, and perception also fostered emergent phenomena. Swarming, flocking, and schooling behaviors in animals created large-scale oscillations that were greater than the sum of individual actions. These collective movements responded to environmental cues while simultaneously influencing local conditions, such as predator-prey interactions and resource distribution. Ecosystems became networks of nested rhythms, with feedback loops operating across scales from molecules to continents. Life's capacity to internalize, predict, and propagate oscillations exemplifies a profound continuity. The same forces that once shaped stars and planets now resonate through the behaviors and interactions of living organisms. Even in the human lineage, the sensitivity to rhythm, memory, and pattern laid the groundwork for symbolic thought, culture, and technological development. Early humans observed celestial cycles, seasonal changes, and biological rhythms, integrating these observations into calendars, rituals, and social organization. Music, language, and storytelling emerged as extensions of rhythmic perception, encoding environmental and social oscillations into forms that could be shared and transmitted. In doing so, humans became not only listeners but composers, translating the subtle pulses of Earth and cosmos into patterns that could be manipulated, amplified, and preserved. In parallel, ecological interactions became increasingly intricate. Predator-prey dynamics, symbiotic relationships, and competition for resources created oscillatory feedback that stabilized ecosystems while permitting adaptability. Species responded to both environmental and interspecies rhythms, adjusting behavior to optimize energy expenditure, reproductive success, and survival. The interconnectedness of these systems amplified the influence of planetary cycles, reinforcing the notion that Earth itself functions as a resonant, living network. Each organism, whether predator, prey, plant, or microbe, participated in the perpetuation of oscillation, translating universal rhythms into tangible ecological outcomes. The layering of rhythms, from molecular to planetary scales, from individual to social and ecological networks, demonstrates the continuity of resonance from the birth of the universe to the complex dynamics of contemporary life. Energy, vibration, and oscillation propagate through every level of existence, shaping adaptation, behavior, and evolution. Life has internalized these patterns, using them to anticipate, coordinate, and co-create temporal order. In this context, the Earth is not merely a stage for life, but an active participant in an ongoing symphony, where the echoes of cosmic events are transformed into living rhythms, cycles, and interactions that persist across eons. Ultimately, the sophistication of memory, perception, and rhythmic coordination exemplifies life's capacity to resonate with both its immediate environment and the broader cosmos. The planetary pulse that began in oceans, winds, and tides has been internalized, amplified, and extended through countless generations, species, and ecosystems. Life has become an interpreter, participant, and amplifier of oscillation, maintaining a continuous thread that links the faint echoes of the universe's earliest vibrations to the living, breathing world we inhabit today. In listening, responding, and creating, organisms of Earth carry forward the first song of creation, a symphony that unfolds in cycles, patterns, and resonances beyond conscious perception, yet profoundly shaping the experience of existence. As life reaches its present complexity, the universe's first echoes continue to resonate through every heartbeat, every cycle, and every breath. The oscillations that shaped galaxies, planets, and oceans now live in the pulses of living beings, in the rise and fall of waves, in the sway of trees, and in the rhythm of night and day. Life in all its forms has become both listener and participant, internalizing and reflecting the vibrations of the cosmos across scales of time, space, and consciousness. In this quiet continuity, there is a profound sense of belonging. Each organism, from the smallest microbe to the largest mammal, is a note in a vast living symphony, contributing to patterns that have persisted for billions of years. Memory, perception, anticipation, and resonance have allowed life to translate these cosmic and planetary vibrations into adaptive behavior, social cooperation, and cultural expression. The echoes of the universe are not distant or abstract. They are intimate, present in the rhythm of existence itself. As you listen, drift, and reflect, consider that every oscillation, every pattern of movement, and every wave of energy is a continuation of a story that began long before Earth existed. The universe spoke first in the language of vibration, and life has learned to respond, to participate, and to create in harmony with its pulse. And so, as night deepens and the world grows quiet, the song continues, unbroken, eternal, and softly, endlessly, echoing through the cosmos, through the earth, and through the living tapestry of existence itself.